Ladies and gentlemen, welcome back to another live stream. Okay, so it's been like I think 3 months since my previous live stream, and honestly I was getting a break from programming altogether. So today would be quite interesting. Hopefully I remember programming. So let's go. Alright, let's first of all live. Please join my Discord server. You can find the link in the description below. Righty. Okay, so I actually got a new domain, codotaku.com. So that would lead you to my channel directly. And there's also one for my Instagram, one for my Discord. So this would lead you to join my own Discord server. And yeah, that's pretty cool stuff. Okay, so let's see what we can do right now. So we're late 23 minutes already. Let me make sure everything's good. Seems like to me. Alright, change branch box. Okay, there's no need for this guy right now. Let's just put it down there. Anyways. Okay. Let's see. Alright. So, I didn't really have a lot of ideas on what to do a stream on. And I was quite, well, how can I say it? Well, kind of bored. I don't know how to describe it. But anyways, so we're back, and we're back with a very difficult topic. So video codecs, right? So we're gonna learn today how to, let's say, make an application that takes a video in, right? Like let's say MP4, and then turns it into MP3, or turns it into some other file format like MOV or whatever. So basically anything that have to do with decoding, coding, and encoding, decoding, like muxing and demuxing videos basically, and audio, though we're probably not gonna touch audio today. So yeah, and we're gonna do it using C++. I'd like to do it in Rust, but in Rust everything is harder, and it's already quite difficult to find resources on FFmpeg, even with C++ and C. So we'd rather start there first. Okay, in fact I did make a live stream before on Rust and FFmpeg, and that was interesting, quite complicated. But anyway, I think we should be able to start. So let's see. Okay, anyways, let's start a new project. So let's go to C-Line. I'm gonna use C-Line, which is a paid JetBrains IDE. I love JetBrains IDEs. And let's get going. So you could use whichever IDE as long as it uses CMake. And yeah, otherwise you're gonna have to like figure out how to actually install it for your own IDE. So yeah, all right, so let's just go with C++26, which is the latest C++ version, and let's just call this, I don't know, FFmpeg testbed. So let's go create. All right, let's go. Alrighty. Hopefully I still know how to program after all this time. So let's go. Alright. Hello world, of course. And there you go, our first hello world. Okay, cool. Now let's figure out how to install FFmpeg libraries. So we're not going to be using the binary. So like in the wild, you're going to find most resources just use the binary directly using the command line pretty much. But for us, we're going to be like gigachads and just use the actual libraries, libav, right? Which is 10,000 times harder to deal with, if not more. Anyways, so let's just look for FFmpeg here. I think they'll know FFmpeg, right? Where is it? So Windows, okay. Hello Marty Flowers, welcome back to live stream. A long time now, man. How's it going? Windows builds from, so you could choose whichever link from these. Of course, I'm using Windows. It should be easier on Linux. You know, just use your package manager, install FFmpeg, and boom. On Windows, we need some extra steps, pretty much. So let's see where we could get this. My God, let's see. Where the heck? Release essentials build, full build. Okay, so we need the shared ones. So there is release full shared. Oh, that's the previous release. Okay, so we're gonna go with the latest release, FFmpeg release full shared. Make sure that it's shared because that's the one that have the dynamic libraries that we need, libav basically. So let's save this guy and let's wait for it to download. Okay, cool. While it's downloading, let's see what we got here. So target, compile. Marty, yeah, long time no see. Nice to see you back streaming. Yeah. All right, we're back after 3 months right now. Hopefully I get my passion back. It's been a very long while since, so yeah. Hopefully I can stream more. I just run out of ideas pretty much, and also a little bit not too motivated nowadays. But anyways, anyway. So target compile options or target compile features. Let's go to target compile features. FFmpeg. Well, we could just use. All right. I still remember how to use CMake. Okay, that's cool. Project name. All right, private. And I'm not using my mechanical keyboard because I kind of find it hard to program it in, honestly. I'm just using a normal, regular membrane keyboard right now. Anyways, so what are the features that are here? I can never remember. Target compile features. Let's check out the documentation. Well, whatever. Let me just do this. Oh, actually it's downloaded already. Cool. Cool. So let's extract this up. FFmpeg is really not easy to deal with. Like most people just goes ahead and use the binary, and that's why we're streaming today FFmpeg. Because it's hard. Anyways, so let's see. Okay, so this is what I have downloaded right now. Hold on, let me see what is the version of this one that I have here. Okay, so this is the version that I have. Right. This is the version that I have. So if anyone is like following my tutorial later, you know, after the live stream, if you want to make sure that there's no problems, make sure to use the same version as me. But otherwise, feel free to, you know, take on the adventure and try a newer version. But anyways, and what else? So we have here the include files. Okay, so we have the headers, and what else? We have the libraries. So this is the static libraries. Well, the static libraries for the shared binaries, right? So it's not like complete static libraries, you know. It's just that in Windows, you do need the static libraries, even though you're linking dynamically, you know. In like Linux, I think in Linux you don't need that, but anyways. Here are the binaries. Here's the actual shared libraries that we're gonna link to. And if you want to use the binaries, here you go, but we're not gonna use these. But that's the binaries. Okay, cool. Doc, we don't need that. Presets, I'm not entirely sure what this is for, but anyways. So, all right, let's go back to our project here. Let's make a new folder. Okay, so new folder directory. What should I call this? Let's go with vendor, I guess. And let's go with FFmpeg. So, and let's just open this up. Okay, open in Explorer. Let's go. And let's do some copy pasting here. FFmpeg, so we're gonna need the include folder. We're We're gonna need the lib, and we're gonna need also the bin. So you're gonna need these three. And in the bin, well, where's the bin? There you go. We don't really need these binaries. We're not gonna use them. And in fact, you may not even use all the libraries that are here, but let's just leave them for now. And let's see how to do this. I've done this before, but that's been a long time now, so we're gonna have to figure it out once again. But anyways, either way, let's go back and figure out what are the options of this target compile features. I can never remember this stuff. Compile features. Right. Okay, CXX, STD, CXX, STD, 26 in our case, I guess. Let's see if this works. Okay, what about 23 then? All right, reload this guy. Okay, that works. So now we don't need this one. And in fact, we're gonna start by using C instead of C++ because FFmpeg examples that we're gonna base our code into would start as C. And then we can refactor it into C++. So just to make sure everything is working fine. So main.c, cscd. Okay, so everything seems to be good until now. Now let's figure out how to do this. Oh my god. Target include directories. So first of all, we're gonna need to add the include directories. So project name, oopsies, private. And we're gonna go with vendor slash ffmpeg. We're gonna add, well, slash include, pretty much, I think. And then we're gonna also do target link directories. There we go. And we're gonna say project name. This is basically just a substitution of the project name. So this and this is pretty much the same exact thing. But I'm using the project name variable instead. So like if I rename my project, it would be, I don't have to rename it everywhere. But anyways, so here vendor slash ffmpeg slash bin, I believe. Is it? Yeah, okay. So we got the include. Is it? I'm not sure. Let's go to FFmpeg's GitHub. Here we go. So this is just a mirror of this. So let's go to, I believe, doc. Yeah. And examples. Okay. So here there is a few C examples of using the FFmpeg library that you could check out. I think one of the simplest one is probably remux, I think. Yeah, so this is the one that would actually basically get like a video, let's say in MP4, and converts it into MOV or whatever formats that FFmpeg supports. And FFmpeg pretty much like supports a whole lot of formats. It's pretty much the most used like encoding and decoding library out there. Because like encoding and decoding algorithms are not easy at all. So that's why most, like if not all, everyone uses FFmpeg for video decoding and encoding. Anyways, we're just gonna copy this example for now. So we could set this up, right? And let's see what we get. Alrighty, let's reload this guy. And let's see. Alright, so this is the errors that we got. Defined reference to AV format. Open input. So we got linker errors. I think without these we're gonna get some other errors. But here you go. So the includes actually works. But without this line right here, it wouldn't work. So let me show you. If I reload my CMake here, these wouldn't work anymore. So this line basically sets up the includes. Okay. Other than that, let's just comment this out for a sec, and let's try this out. So as you can see, we're getting linker errors right now in defined reference. So we have linker problems. How are we gonna fix this? So I think, let's try, instead of bin, maybe lib, if I remember. Let's try this out. And let's see. Oh yeah, my bad. So we got the linking directories, but we didn't link the actual libraries. We have just set up the directory, okay? So yeah, I haven't programmed CMake for a while. Okay, so project name, private, and then we're gonna link the libraries that we're gonna need. And in this case, what we're gonna need is, I think probably AV-codec, and maybe AV-format, and also AV-util. I think maybe these three. And let's just try these out, actually. Let's see. Oh, crap. You actually have built it. What the? Okay, cool. So we don't have linking errors anymore. It actually got built successfully. But the process is finishing with exit code -1, meaning there is a runtime error right now, not a compile time or link time error. So how are we going to solve this? I'm not getting the error here. It's probably, hold on a second. Let's just run it directly and see what's up. CMake build debug, FFmpeg testbed exe. All right, so it's probably because of the binaries. It needs them. Now for the binaries is quite interesting. So basically we have set up the linking to the lib libraries here, to the static libraries, but it can't find these binaries, okay, DLLs, right? I think that's probably the problem here. And just to make sure, what I'm gonna do right now, just a dirty check, we're just gonna paste in this stuff here, these DLLs, right? And let's check if this works now. Really? There you go. It actually works right now. There you go. So input, output, API example program to remux the media file with libavformat and libavcodec. The output format is guessed according to the file extension. So right now it actually works. So basically what we needed is just to copy these binaries, these DLLs, into the actual build file, like basically next to the exe file, right? So now the problem is we don't want this, like we don't want to copy it, you know, manually every time. That sucks. We gotta figure out how to actually copy it using CMake automatically. Automation age. Okay, so how are we gonna do this? CMake copy files. Okay. Let's see, add custom command, yeah. Configure file. It creates a copy. Ooh. Nah. I think this is the one that I was working with personally. So add custom command, target foo. Target is basically the target name, I think. Post build, because this has to happen after the build. Honestly, it doesn't really matter in this case, but anyways. CMake command -e copy. So this is the operation that we're gonna do. We're gonna copy from, now this is the source directory that we're gonna copy from. So here we're gonna copy from, I think, vendor / ffmpeg / bin, right? So vendor ffmpeg / bin. Cool. And we're gonna copy it to, let's see, so CMake -build -debug, Or actually, it's probably just binary directory. Yeah, let's try this out. Let's try this out. And let's actually remove that thing. Open in. And oh, I think I've removed it already. Strange. Anyways, let's try this out and see if it works. I think I probably gotta, yeah, let's reload the CMake here and let's test this out. Okay, but why we have nothing? Okay, it's actually there. But for whichever reason, it's still doing this error because I'm using this. But if I just ran the executable directly, it does work. And that's because the environment here, I think, yeah, the working directory. So this should be changed. I mean, we can actually just put that guy into, but honestly, I feel like, I mean, we could put it into just the CMake source directory, but no, because if we do, then what's gonna happen, we're gonna be, like when we upload it to GitHub, it would get included. So no thanks. All right, let's just do it like this, okay? Let's just change the working directory for now and change it to the project path build directory. And yeah, let's just copy this guy. Let's copy this path and let's go here, edit, and working directory, apply. Okay, let's try now. There you go. So right now it actually works perfectly fine. And we have set up FFmpeg finally with Windows. It's way easier on Linux. You don't have to do any of this business, just install the package, I think. And other than, of course, linking to it and stuff like that, but yeah. All right, so let's actually get into the code and let's try to understand it, okay? So let's start by just kind of clean this up first of all, I think. Let's join the declaration and the assignments, please. I'm gonna do that in the whole project. So basically this code is kind of a old style code, like where they basically declare the variables and then assign them later. That sucks. So let me just fix it or refactor it in the whole project. IDE can do that. There you go. Other than that, what else? Let's see. Sure, add const to the whole project. So any variables that are const should be const. There we go. What else? A local variable on the stream can be made pointer to const. Okay, so constant pointers. There you go. And anything else? Cannot resolve symbol. What the heck? Oh, I see. Well. I don't care. Cannot resolve symbol. The value is never used. Okay, so here we don't need to define this. That value is never used, I think. Declaration can be joined. Sure, why not? Pointer may be null. Pointer may be null. Doesn't matter for now. Zero constant can be replaced with null PTR. We're in C. But the newer versions of C, I think they have null PTR. So, okay. All right, cool. What else? Can be made const, sure. And I think that's it for the automatic refactorings of my IDE. Okay, so let's get into the actual code right now, pretty much. We're gonna ignore this one for now. Here we're just using libavutil and libavformat to get these files. So here mem for memory, timestamp, and AV format. Yeah, and then actually let's first of all try this. Let's see if it works. Hold on a second. Let's see if this works. So first of all, I need a video to test on. Well. Let me actually stop just the screen for a second until I find some video. Let's see, display, desktop audio, no need, and display capture. Okay, cool. Let me see some video real quick. Okay. Just trying to find a video real quick. Okay, so I got this little video. Let's see. I'm gonna put it here. Okay, cool. Let me grab back the desktop audio and the display capture. There we go. All right, so I got this MKV video right here. And so we want to turn it into an MP4. So how are we gonna do this? Well, we're just going to use the executable so that we have made the program that we have made here, CMake build debug slash what is it called again? FFmpeg, yeah, test bit. And we're gonna give it the file, and we're gonna give it what we're gonna call it. So output, let's say the output.mp4 or video.mp4. So this is going to be a little bit slower than average because this is, you know, debug, not release build. But anyways, it also doing some logging, which is going to make the process much slower. It basically gives some information about the packets, as you've seen here, like the packets of the video. Right now, it's actually turning this MKV file or MKV video into MP4. There we go. And it's done. Let's go. It could have been way faster if we didn't have login in, and also if we didn't, if it was release mode. But whatever. Let's open an Explorer here, and let's see this video if it's working or not. Okay, just gonna try some piano. Alrighty. And so it actually works. We have converted an MKV video into an MP4. Now let's actually see how this works. So we got the main function, of course. We got AV output format equal to null, it's a pointer. Input format context and output format context. Got the packet and a return code here. We got stream index equal to 0 and stream mapping equal to null. Okay, so here we're just checking if there is like 3 arguments or not. Otherwise, we just give the user help message. So tell him how to use the program basically, and we return 1, basically failure, exit failure, right? Meaning that the program haven't ran successfully. Now here we got the input file name, which is the first argument on the command line of the program, and then the output file name, which is the second argument. And here we got the packet, so we're allocating a packet data structure. So if not packet, then we're just basically gonna print to standard error, could not allocate AV packet anyways, and we're gonna return exit failure. Okay, so all right, so if return, so here we're basically gonna put the return code into this variable that we created earlier, this integer, and we're gonna check if it's less than 0, because if it's less than 0, then there's an error, could not open the input file. So here AV format open input, and we give it address to input format context. So input format context, as you can see, is equal to null, and since we're given an address here, we're actually giving a pointer to a pointer. So basically this this function right here would actually put like would change this pointer, right? It would change it to whatever input format context. So basically after it loads the file, it's gonna put a pointer to it here in this variable, basically. Here we're giving it the input file name. So this is basically the file name that the user have gave us, the path. And here we're just saying null PTR options. Like a lot of these FFmpeg functions, you're gonna find an options at the end of it, right? So just for some extra options. So it's kind of like a dictionary, or basically a C dictionary. But whatever, that's irrelevant right now. The format here, so basically you give it the format that you're expecting this input file name in. If you give it null PTR, it basically means please guess the format for me, which we can actually do here because we have the input file name. Otherwise, if we didn't, we have to, of course, explicitly tell it what is the file format. But anyways, here we're going to end. This is kind of discouraged in the community, but this is how you do actual real, like, proper error handling in C, unless if you want to go crazy. But anyways, this goes to a label called end at the end of the file, I think. There you go. So label end here, and basically there's just some cleanup that we can look into later on, right? And here, after we're all done, we're gonna return exit success, basically 0. Or here, exit failure. Anyways, let's go back to where we were. Where is that? Okay, so we were here. Okay, so after opening the input format context, right? What we're gonna do? We're gonna try to find the stream info. So basically, videos have multiple streams. So you could have like a video stream, an audio stream, or even multiple audio streams and multiple video streams. And also, let's say subtitles and whatever have you, right? Depending on the format, right? So here, we're actually trying to find that info about the streams. Options just 0, basically no options. And here we're given it the input format context that we have loaded earlier from the file, right? So the video file that we have loaded. And here, okay, I failed to retrieve input system information, stream information. Okay, so here we got AV dump format. So if you check what we have here, if you check out, yeah, so this AV dump format basically logs to the console or to the, you know, standard output, the format specification of the video, right? Of that input format context, sorry, which is this guy right here. So we have input 0, Matrushka. So this file is actually MKV, which is Matrushka. WebM from this metadata encoder. So this is the encoder name of this file, of this video. The duration is 20 seconds. The bit rate is 5058 kilobytes per second. And here's the streams. So we have two streams. We have the first stream, which is video, H264. So this is the encoder that is used to encode this video, right? High, so probably high quality, though I'm not sure. UV 420p. This also goes into the pixel format stuff anyways. TV, BT, blah, blah, progressive. And here we got the dimensions of the stream, of the video stream, which is full HD in this case. Okay, so 60 FPS. This is the, what is it called? I don't remember, what is it called? The ratio, yeah, the ratio, the resolution, but anyways. Metadata, duration, and we got another stream. So the second stream is actually audio. So AAC, LC. Let me make sure the video is good. Hold on. Seems all good to me. The mic is on, the camera is on. Good, good, good. Just like check real quick. Anyways, so audio AAC, this is the encoder of this audio. This is the frequency of the audio. So 48,000 hertz stereo. And this is the title of it and the duration. All right, cool. And we also got the output. Now, this is not the login of this one, I think. Where is it? Output 0 MP4 to yeah, actually this comes after this. So this AV dump format, if we removed it, then we're not gonna get this logged in. Though this is just for informational purposes. It's not, you know, related to the functionality of this program. Okay, now we have AV format alloc output context 2. Right now we're gonna set up, so basically this part right here, hold on, up to here, right? Well, the packet is not really needed here actually. The packet is needed afterwards when we get to the loop of the packets. Why the heck this is, hold on a second, why this is like this, unreachable code, strange. Well, we could check that later. Anyways, so before the loop, this is where we really actually need the packet. Leak of memory allocated in function main. Oh, so I see now why that's the case. Yeah, gotcha. So we actually really need the packet just before the loop. But since, you know, there is the allocations first, then the deallocation. So I see. So my IDE right here just saved me from a memory leak, pretty much. So let's just get back that code into its place. All right, fine. Anyways, there you go. Okay, cool. Anyways, so this part right here is the one that is used to load the video, load the input video. Right, now after this, here we're actually preparing the output video, right? Not in the disk, just in memory, right? So we're allocating the output context that we're gonna use to decode the videos. So here we could not create output context. Cool. Now here's stream mapping size. Okay. Stream mapping size is equal to input format context number of streams. So here we're getting how much streams in the video, and as we've seen earlier in the login here, we have 2 streams. So this would actually equal to 2 in the case of this video. And here we got stream mapping AV calloc, stream mapping size. So here we're basically allocating an array. This is just like calloc, but for libav. Allocate a memory block for an array with AV malloc z. The allocated memory will have size times number of bytes. And also, since this is calloc, I think it would be initialized to 0 too. Otherwise, it would be called malloc. Anyways, so here we have how much elements in the array of the stream mapping. So we got 2 in this case, and size of stream mapping. So anyways, if not stream mapping, then we got an error, basically out of memory, AV error out of memory. Anyways, here we got the output format. Output format. Where this is being used. Well, I guess we're gonna see about that later. Anyways, let's actually see real quick something. Like if we actually do, but though the problem is if I want to debug this, I need to pass in some arguments. Okay, cool. Let's actually add some arguments here so we could debug this. How we could do that? So we got the video here, though we could just put it for now in the build directory just to make our lives easier, I think. And let's copy the file name here, I think. Oh, hold on a second. Let me make sure I'm seeing the extension. View show file name extensions. Okay, cool. Let's grab the name of this file. And where are we gonna put it? Yeah, let's go. Never mind. Anyways, so here we got this file name of the input, and then we need the output, which is gonna be output.mp4, and we're gonna apply this. And let's see if this actually works. So if we do, let's put a breakpoint somewhere. So after we have loaded the video, I'm just gonna put a breakpoint there, and let's see what we're gonna get. Cannot input no such file directory. So it's probably based in the file path. Okay, let's see. So what I'm gonna do is, let's see, CMake -build -debug / that, maybe apply. Let's try this now. Oh yeah, there you go. So right now we're into the debugger. Cool. So let's see what we got. So as you can see, the input file name here is the path of the input. The output file name is output.mp4. Amazing. And here, where is it? Okay, so this is the input format context. There we go. Oh, what we got here? So we got a lot of crazy stuff right there. Okay. So let's see. So you got AV class here. This is some crazy stuff. So this is the I format. So the name of the file, the long name, the extensions, the MIME type, and PB. What's that? Oh, I see. AVIO context. Okay. Now here's the streams. So number of streams is 2. And the streams that we got. Hello, Theo Paris. Welcome to the live stream. How is it going, my admin? How is it going? Are you an admin in here? Oh, you're not. Okay, let me add you as a moderator. Standard managing. I can't see this whole thing. Chat modes. Let's go with this, fine. There we go. All right, anyways, so we have streams, codec par, and what else? This is the codec ID. So as you can see, there's a lot of cool stuff here. There's the frame rate as an AV rationale, or rational. Anyways. Chapters, null, URL, duration, bitrate. So there's all these information is right here, as you can see. But anyway, that's not the deal right now. The deal right now is to see something else. So that is just a side mission, a side quest. So let's actually go to the next line. Could not create. Okay, so stream mapping size. Let's run that line. And here we go. Stream mapping size is equal to 2. We got it from number of streams from the format context. Then here we're going to allocate an array stream mapping. So stream mapping, there you go. So this is an array. So let's view as array and enter size 2 because we know the size, but the program here doesn't know the size because arrays in C is just like 2 elements, right? Sorry, arrays in C is just a pointer without a size. So there you go. So we got 0 and 0 here. And they're integers. Okay. Integers. All right. Let's go to the next one. And the output format, OFMT, is MP4. There we go. Oh, I see, I guess. Hold on. So when we allocate the output context, we actually give it the output file name, right? So we give it the file name of the output video that we're going to create, that the program will create, right? And we didn't give it a format name, so we're basically telling it to guess from the output file name, right? And then afterwards, we're actually taking the output format from the context. So here, as you can see, you have guessed it right, so MP4, because we said to convert it into an MP4. There you go. So we got the output format. Cool. Now we're going to loop from 0 to number of streams. So basically 2 times in this case. We're going to loop basically through all the streams. And what we're going to do, let's see. We got the input stream. The input stream. Hold on. Input stream. And okay, so this is the input stream of the first stream basically, and then we're gonna get from that, we're gonna get the codec parameters, so the parameters of the codec. And here you go. So here we got the encoder ID, the codec ID, which we can use in FFmpeg to tell FFmpeg what codec we're interested in. So anyways, here we're basically checking to see if the codec type, so in this case the codec type is video, so this stream right here is of type video. It could be audio, it could be subtitles, it could be etc, etc. So as you can see here, there you go. So this is all the types of streams that are possible. There's unknown, video, audio, data, subtitle, attachment, and NB. Well, this is actually just the number of elements in the enum. So yeah, so we got just this basically, and this one is an error. So if we want the valid ones are these, so 5. Okay, cool. So here we're checking if the codec type, so if the stream is audio, video, or subtitle, and what we're gonna do, so if it's not that, and not that, and not that, so if it's not one of these guys, then we're basically gonna set the stream mapping in the index I, so in the same index as the stream, to -1. Meaning we're not interested into this stream. So basically here we're basically like filtering the streams that we're interested in, because we don't want to feed a stream that is possibly not supported or not compatible with whatever operation we're going to do next, right? So here we're basically filtering the streams of the video into the streams that we're actually interested in the program, right? So stream mapping I equal to stream index plus plus. So we basically advance the stream index and we add it to the stream mapping. So yeah, how can I describe this? Stream mapping I equal to -1. Okay, so if it is valid, then we're gonna actually add it to the array. Otherwise, you're gonna set it to -1. Yeah. Anyways, so here we got the output stream. So let's actually advance this. What the heck is happening here? Why can't I advance this? What the heck? What did I do? Strange. Let's try again. Somehow I lost that. Anyways, let's step over. So we have already talked about this. So this is the first iteration. As you can see, I equal to 0. So in this case, the stream is we are interested in because it's video. It's a video stream. And so we're gonna add it to the stream mapping array. And now we have the output stream. So AV format, so we're creating a new stream. And here we're passing in null. I think null so we can guess the stream type, is it? No, hold on. Add a new stream to a media file. We demuxing, so we're adding it to the output format context, as you can see here. And of course the output format context at this case, right now, it's actually like, it's empty, it doesn't have any streams. So when demuxing is called by the demuxer in read header, should be called by the user before AV format write header. So right now we're actually muxing. User is required to call. All right, so newly create stream or null on error. Okay, in use does nothing. So the second parameter is in used and it does nothing currently, at least. I don't know. And if it returns null on error. Otherwise, it gives us the newly created stream. Cool. So if not outstream, of course, we have an error. There we go. So we basically give it the AV error unknown return code, and then we go to the end. All right, cool. Now here we actually copy the codec parameters. Copy the codec, the contents of SRC to the DST, and the allocated fields in destination are freed. Replace with newly allocated duplicates. Okay, so basically this outstream and this input stream are the same type, right? So AV stream. And what we're doing here, we're basically copying the codec parameters from the input stream, right, to the output stream, right? That's exactly what we're doing here. So we don't have to do it manually. We use this function. Fail to copy codec parameters. I'm not sure what could fail there, but whatever. Outstream codec parameter and codec tag. We removed this because I think it's supported in some formats. Yeah. So we actually remove it entirely. We don't care about that. And after that, we AV dump format again. But this time, instead of the input format, we actually dump the format of the output context. What is that index? the index of the stream to dump information about. Oh, so this the 0th string. URL to print. So it is an output, yeah. So this is 1, basically true. And now we got the output file name. But here on AV dump format, there you go, we got his output 0. Cool. So let's go here and let's see what we got. So console, let's go through this. Okay, let's go. So of course this would happen twice because we have 2 streams here. This one and the other one. And in this case, this filtering is useless because we only have 2 streams and we're interested in both of them. So the stream mapping would just hold, where is it? Stream mapping, there you go. It would just hold 0 and 1, so nothing crazy. But let's say we have 3 streams, right? And the second stream is off. What we're gonna have here, we're gonna have 2, right? But we're gonna have 0 in the first one and 2 in the second one instead of 1, right? So the 1 would be discarded basically. Anyways, so let's go to the next iteration here. Okay, there you go. So now AV dump format. Let's see what we got. Apparently it doesn't print it because there's probably gonna need to flush the console, so I can't maybe show you right now until later, or yeah, pretty much. Actually, I could show you maybe, yeah, I could show you before. There you go, here we go. So this is the AV dump format of the output context, and let's see, there you go. So MP4 video. Okay, well, I have already shown you about this, but there you go. So now what? If not OFMT flags and AVFMT no file, what the heck is this craziness? AVIO open PB out file name flag right. I'm not sure honestly what the heck is going on here. But I don't think it's... Yeah, I remember this AVIO. I think, if I remember well, it's like maybe some video formats like have multiple files, right? So instead of one file that have all the streams and stuff, you have one file but it uses other files, so maybe you have to load the other files. Though I'm not sure. I'm not sure what the heck is this part of the code does. But anyways, let's see if it actually works. Yeah, it does actually do the job here. AVFMT no file. We have no documentation though. AVFMT. Demuxer will use AVIO open. No open file should be provided by the caller. Demuxer will use AVIO open. So I think this is some automatic crap, but whatever. Anyways, let's go to the next one. So output file name. All right, so here we start to write the header of the output video. There we go. Is there a better description here? Allocate the stream private data and write the stream header to an output media file. Okay, whatever. If read, so this is good. All right, so right now we're actually in the loop of the packets, right? Of the packets. So here we're actually reading the frame. So it basically every frame, every time we're gonna read a new frame from the input file or in the input context, and we're gonna make sure it is valid, and then we're gonna get the input stream. So streams, packet, stream index. Okay, cool. So hold on a second, I'm gonna come back. Okay, I'm back. All right, so where we were. All right, so we got the input stream here. Packet stream index. So the packet would actually tell us which stream it is in, because like when it comes to packets, it's gonna come interleaved. So like you're gonna have like, let's say n numbers of video samples, or like video packets, sorry. And also at the same time, you're gonna get audio packets, because like if you're let's say playing the video, what's gonna happen is that we want audio packets and video packets at the same time. So like let's say frame 1, we want to get the video of that frame and also the audio interleaved. So that's basically what's happening here. We're getting the stream. In this case, what is it? Let's see. The first packet, what is it? Input stream. There you go. So the first packet, is it video or audio? Codec parameters. Okay, so the first packet that we got here is video. Cool. Let's go to the next one. So if packet stream index is greater than, so here we're checking if we have that, if we are interested in this packet, right? Or sorry, if we're interested into this stream. Remember the stream mappings, like the stream mapping array that we have made earlier, where we filtered only the packets we're interested in. There we go. So here, if we're not interested into this packet or this stream, then we're basically gonna enref this packet, right? Otherwise, and we're gonna basically continue to the next packet. So we're just gonna go back and go to, in this case, we are interested in it because it's a video packet. So here we got stream index, packet stream. So packet stream index, stream mapping. Now let's see if we want to actually remove the audio from this video, then we could probably just add in, like filter out the audio packets. And there you go. I mean, I'm not sure if that would work, but we could try it. Sure, why not? Packet stream index equal to stream mapping, packet stream index. So we're just using the array of the mapping here. Because once you filter them out, then the ID, like the index of the streams, would not be the same as 0, 1, 2, 3. It could be different, right? So here we're using that array that we've made earlier for the mapping. Okay, cool. Now here we got the output stream. So we're basically getting the output. Hold on. Yeah, so remember earlier we made the streams, right? In the output too, depending like from the input stream mapping. Now here we're actually gonna reference that output stream, and then here we're just logging the packet. This is just a helper function to log the packet. Unfortunately, I don't see it here in the log, but I could show you here though. There you go. So this is just some logging, some information, some code decoding information here. So in this case, the first packet is duration time is 0.016, which makes sense because this is a 60 FPS video, and like 1 divided by 16 would of course gives you 0.016. So every frame is actually 0.016 seconds. And now here's stream index 0. There you go. Duration 1000. What the? Duration time. Oh, so input and then output. Yeah, so there's some other thing right here. Interesting. Whatever. Timestamps are inset in a packet for stream 0. This deprecating will stop working in the future. Fix your code to set the timestamps properly. Well, it's not my code. It's the official FFmpeg example code. Wow. Like. So anyways, this is just a warning basically. Alright, so the next packet in the video, let's see, can we catch some audio packets or not? Duration, stream index, nah, this is also video packet. This is also video packet, so 3 video packets. And finally, we're getting some audio packets here. So this is the stream index 1. So we're getting 1 audio packet, and then we're getting 1 video packet, 1 audio packet, 1 video packet. As you can see, it's interleaved, right? So sometimes video, sometimes audio, sometimes video, sometimes audio, depending on the frequency of the audio and the frame rate of the video. So yeah, because you know, if you just like, let's say, give the video packets first, then the audio packets one after the other instead of interleaved, then what's gonna happen is that we're gonna need to wait until we load the whole video and the whole audio. We can't like progressively show the video for the user. Let's say if we were making a video player right now, we can already, since we have the audio packet and the video packets of this particular frame, we can already actually show it and, you know, play the sounds before we actually go to the next packets, to the next frames, right? So yeah, anyways. After that, we're copying the packet. So we're saying AV packet rescale TS. AV packet rescale TS. I think this is probably have to do with, hold on. Convert valid timing fields, timestamps, durations in a packet from one time base to another. Timestamps with unknown values, AV no PTS value, will be ignored. So this one, I've seen that AV no PTS somewhere. I'm not sure where exactly. No, I think I've just seen this no PTS, but anyways, whatever, who cares. So we got the packet on which the conversion will be performed. So we got the packet that we have loaded from the input stream, or the input video. And here the source time base in which the timing fields in packet are expressed, time base, and the output stream, destination time base to which the timing fields will convert. In this case, I don't think we need this because it's going to be the same frame rate, like of the input video with the output video. But I think this would be useful, I think, if we had the video output in a different time base or in a different frame rate, I believe. I'm not sure, but we could try it out. So that's something. And now we have packet pause. What the heck is this? By the way, did I unmute myself? Cool. That would have been tragic if I didn't. Anyways, so packet POS. I'm not sure why it's doing this. No clue. But anyways, and here we're logging the packet. So this is just logging. Anyways, let's go to the next ones. Let's go. But let me make sure one thing, that the time base is the same. So here, this is 1 divided by 90,000 and 1 divided by, ooh, what the heck? So in this case, the input stream and the outstream have different time bases. What the? Honestly, no clue why that's the case. Maybe time base is actually something else, not what I thought. Really? Video time base. Let's see if we can get something here. Okay. This is the fundamental unit of time in seconds, in terms of which frame timestamps are presented. In terms of which. So this is kind of like the unit. Decoding set by libavformat may be set by the caller before AV write header to provide a hint to the muxer about the desired time base. The muxer will override this field in time base that will actually be used for timestamps. I'm not sure honestly why that's the case. But I think this is probably something like just like units or some crap, but it's probably not the frame rate. But anyways, whatever. Here we got interleaved write frame. Interleaved because sometimes we're gonna have video, sometimes we're gonna have audio. So this function would probably take care of that. Write a packet to an output media file, ensuring correct interleaving. There we go. The function will buffer the packets internally as needed to make sure the packets in the output file are properly interleaved. There we go. Usually ordered by increasing DTS, basically timestamp, like the time that packet comes in. Callers doing their own interleaving should call AV write frame. Okay, instead of this function. So instead of doing AV write frame and doing some other crap, this function will take care of the interleaved stuff for you. Using this function instead of AV write frame can give muxers advanced knowledge of future packets. Okay. Using this function can give muxers advanced knowledge, improving the behavior of the MP4 muxer for the VFR, so variable frame rate content in fragmenting mode. Crazy stuff. This is some interesting stuff. But anyways, whatever, let's go to the next one. So here we're basically writing that packet into the output video file. And now packet is now blank. AV interleaved write frame takes ownership. Okay, so it's reference count. So the packet is reference counted. And when you say AV interleaved write frame, the function now is responsible for the reference counting, I think, or some crap. I don't know. Takes ownership of its contents and resets packet. Oh, so I guess right now the packet is actually empty. Yeah, because like I think the packet is actually a pointer, right? Is it? Yeah, I think so. Hold on though. Where the heck is packet? Okay, so yeah, it's a pointer to a packet. So this would probably become null after that function. Let me check. Where the heck I was, bro? What the heck? Okay, so let me just remove that breakpoint real quick. And let's put it in somewhere around here. Okay, let's go debug, and there we go. All right, so here let's see the packet. Okay, so we have some packet here. It's a pointer, and now if we go to the AV interleaved frame, there you go. Oh, sorry, so the packet is actually allocated. Yeah, so the packet is allocated. It won't be null, right? But actually, as you can see here, it actually got reset. So all the fields got reset into their default values. BTS and DTS seems to have like invalid, like just an arbitrary value. Buffer, as you can see, null, size 0, data null. Okay, so that's what it means to reset a packet there. So that note in referencing is necessary. Okay, this would be different if one used AV write frame. So if you use AV write frame, basically you have to handle the referencing yourself. In this case, interleaved write frame would do the job for you because it takes ownership of packet. Anyways, whatever. All right, now we basically go to the next packet, and basically the same process happens again. There we go. So basically, now let's go to the next one. Well, continue, please. There you go. So after processing all the packets of the video, which is basically all of these, as you can see, we're logging all of them right here. But anyways, here we're gonna say AV write trailer. What this does, so you can remember that we have written the header of the output format context before we start to write this, like the packets into the output. Now we just write the trailer of the video, because basically when it comes to videos, we have a header and we have a trailer, and they usually have some information about how, let's say, to play the video. Let's say for media players, they need to know some information in advance about the video, like what its frame rate, etc, etc. Wa alaikum assalam, WoGG Kieran, welcome to the live stream. How's it going, man? Long time. AV write trailer. So that's basically it, honestly. It's also useful, I think, for streaming. So right now I'm live streaming, and by the way, OBS, the program that I'm using right now to live stream, is actually using FFmpeg under the hood. Yeah, it's using libav. So whatever I'm doing here, it's using it. Right? So if you're live streaming, you're gonna need some information beforehand to give it to the the thing, to yeah, to the playback, right? So the one that you're using right now, so YouTube, right? The one that you're using to do the playback. Long time making gear in Blender, geometry nodes. That's very interesting. I should honestly check out the geometry nodes. I do remember checking them out. They were very, very interesting, though I have never got into details on them. But it seems very interesting, just like shaders basically, but much cooler, because instead of, you know, dealing with fragments, you're dealing with actual geometry, which is very insane. I should probably check that out at some time. But anyways, so here, AV write trailer next. And finally, we free the packet. Why we're freeing the packet? Yeah, so here we're reaching the end. Right now, we're just going to be deallocating stuff. So before we have allocated the packet, so if an error happens or we actually just reach the end of the program successfully, then we have gonna free the packet that we have allocated, and we're gonna close the input format context. So we're basically closing all that stuff. And now we're gonna close the output, and we're gonna close the, well, what the heck is this? Close the resource accessed by the AV/IO context. Interesting. So like, let's say if we open some file, then we're gonna close it. And this PB, I believe this IO context stuff is basically describing how to load a file, I think, if I remember. Like if we check some, is there some AV/IO stuff here? Where can I find it? Oh yeah, OFMT context PB. Where is it? PB. Oh no, context. There we go. There you go. But it's null right now. Yeah, it's already deallocated. But we could check it out. Okay, let me do something like this, like this. There we go. So this is what the AV/IO context holds. So as you can see, byte stream IO context. So as you can see, there's some function pointers that you could set on to tell like the functions of FFmpeg, how to read packets, how to write packets, and how to seek them, how to read pose, how to read seek, and of course the buffer stuff. What the buffer is for, I'm not sure, basically for the IO stuff. But anyways, and that's pretty much it. Anyway, let's go to the next one. AV free P. What the heck is this? Freeze a memory block, which, oh yeah, okay. So this is just like free for malloc, but this one is for AV malloc and calloc, right? So we're just basically deallocating the array that we have allocated earlier. And finally, we're gonna check if there is some return code that is an error. And if it is, then we're gonna turn that into a string, so we can give the user a meaningful description of the error that have occurred in the program, that have made us jump to this end label. If we did, in this case, it was successful, so we're just gonna return exit success. In this case, we're gonna return exit failure. And there we go, we're done with the program, done, boom. Okay, so we have basically have gone through the whole thing, gone through the whole program line by line. I'm not sure, like I've never done, I think, such type of streams. So usually what I do is I basically write the whole thing in live stream, and of course it takes a lot of time and it takes a lot of efforts from me too. So, but this time I've done it a little bit differently. I basically copied the official example of FFmpeg and I've gone basically through it line by line, debugging it and showing you exactly what happens under the hood, right? And trying to explain every line, basically. And here we have this log pocket function that I haven't actually told you about, but it's just logging, pretty much nothing crazy. So we're getting the format context, we're gonna get in the packet and the tag. Okay, here we're getting the rational time base of the current stream of the packet. Okay, so basically the current time base of the packet, right? And here, as you can see, we're saying printf, pts, blah, 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 whatever. And here we're using avts to stir. Convenience macro to return value should be used only directly in function algorithms, but never stand alone. What the heck? avts make string. avts to string. Timestamp to string? Yeah, I think it's timestamp to string, right? So it's basically turning that timestamp, which is just rationale, yeah, AV rationale, I think. Is it? No, it's actually integer 64t. Yeah, it's probably turning it into a human readable format, maybe? I'm not sure. Anyways, AV time TS2 timestir. Same thing, probably. Yeah, here we're actually also passing the time base, so we can take it into consideration, right? Maybe. Anyways, whatever. So that's pretty much it. Yeah, and we're just printing all this stuff, pretty much. Nothing insane there. So please tell me in the comment section if you like this kind of streams where I, instead of writing the whole thing from scratch in live stream, I just go line by line debugging it and showing you exactly what happens, just like this stream right now. Pretty much. Tell me your opinion in the comments after watching this whole video stream. So other than that, we're gonna do some experiments before we end the stream. So what about, let's say we want to remove the audio from the video. We're not, like, instead of just converting the video like it is without any modification, let's try to do some modifications. I'm not sure if I can do that, but we're gonna experiment right now. So hopefully it works. Okay, so right now the video that we have is actually does have some audio. Let me make sure I have audio on. Yeah, I do. So let me show you, right? So open in Explorer. As you can see, it does have some audio. Let's try to remove that audio in the output video. And let me just show you. Where's the output file? It's I'm not sure, but let's just remove these, right? Now let's try again. There, what the? Was it really that fast? No way. Strange. Well, I guess it did. I don't know how that happened. But as you can see, the output video does actually have audio right now. Let's try to change that. Let's say we want to convert the file format of the video, but also to remove all the packets that are audio. So I think what we could do, we could remove audio from here. Too simply, I think. So let's try to remove this. Basically in this, the filtering of audio here. So what's gonna happen, right now stream mapping array is an array of integers of, like, it contains 0 and 1, right? So 0 and 1. But right now, since we're not gonna include the audio, we're gonna filter out the audio. What's gonna happen, it would hold 0 and I think -1 for the second one, or it's just gonna hold 0, I think. I mean, let's check. Let's actually see what's gonna happen real quick. Let's do this. So AV, where is it? Stream mapping. There you go. Okay, so instead of 0 and 1, right now we have 0 and -1. So we're not including the second stream of audio. Cool. So let's see if this actually works. Let's just run the program. And boom, oh my god, that's super fast. I really do not know how the heck it is that fast. But anyways, let's see if it does have audio. It doesn't. Okay, cool. So right now the video is muted because we didn't include the second stream. And even if we check the format, the dump of the format here, why didn't it get included though? I'm not sure why that's the case. It's probably here. And there you go, we got one stream in the output video. Just one stream. Cool. So right now we're actually muting. What about changing the frame rate? Can we actually do that? I'm not sure. Let's see. But let's first of all keep the audio. We do want the audio right now. Let's try right now to change the frame rate. How we could do that? I have no clue. Well, I guess let's ask Google about this. How to change frame rate. Hopefully it's not insanely hard to do. How to change frame rate in FFmpeg libav. Libav reducing extremely high frame. Adjust FPS. Changing its frame rate, but I'm a bit lost in how to do it. This is what I have in mind. Okay. Change the frame rate. Must first decode the video frames as you receive them. Don't throw away the AV packet before decoding to an AV frame. After decoding, you can throw away every other frame. Or whatever you decide based on your frame rate. Don't need the DTS after decoding. Don't change the PTS because it's the presentation timestamp and you want to display the frame in the same place in the timeline, only fewer frames. Okay. So what it's basically saying, we could just throw away like let's say we have 60 FPS. Then what we could do, we could just throw away, like, accept one frame but reject the other, essentially. That kind of sounds finicky. Well, I'm not gonna throw the the audio packets. I'm only gonna throw some video frames, basically, I think. And the PTS would probably be fixed by this function, I think. I mean, let's try it out, honestly. Let's try it out. First of all, let's check if this frame right now is audio or video. So how are we gonna do this? Let's see. So if packet is my, where the heck is this completions coming from? What the, no clue. Is it AI assistant of JetBrains ID? I don't know. Anyways, whatever. Let's see what we have here. So yeah, let's check. Yeah, so here we got the stream. So this is the input stream. Okay, so this is what we need. Let's check the input stream dot. And what's that called? Is it codec params? Yeah. There you go. Okay, so we're gonna check the codec type. If it's video. So if it's video, then we're gonna actually see something here. Let's say we got some integer. Can we do Boolean? I don't know. Discard video frame false. So we're gonna say if that's the case, and now let's say if discard video frame, well, for sure we're gonna actually equal to, well, not. So we're basically gonna flip that, right? And what we're gonna do then? So first it would be true, so we're not gonna discard the first frame. That's good. So if discard video frame, then we're gonna basically continue, I think. AV packet in ref and continue, just like this, I think. Otherwise, we're good. Does that make sense? I think so. Yeah, I guess let's try this out. There you go. So if everything worked well, then it should be 30 FPS or something like that. But How can I check that? No, it does show 60 FPS, not 30. Does the video even works? Well, let's actually see. Oh shit. What the heck? We have corrupted the video. Alright, so oh my god. What the heck is this? So right now we're basically like taking the video packets and we're basically discarding, like basically one discard, the second doesn't discard, right? So don't discard it, then discard the other one. Basically every other one we're gonna discard that packet, that video packet. But as you can see, I have corrupted the video. Interesting. So that's a failed experiment, I guess. But or whichever you decide, you don't need the DTS after decoding. Don't change the PTS because so that didn't really help. Decoding to an AV frame. Let's check something else. No, this one is talking about the actual binary. Like not the library, but the binary. This one doesn't have any answer, I think. Yeah, no clue. Time base. Is there some actual example for that though? That would be cool. Let's see the examples that are there. There's some decode audio, decode filter video. Transcode. What the heck is transcode? Resample, scale. Oh, scale in video. That seems interesting. But hold on, what is transcode? I forgot. Well, from one format to another by adjusting parameters such as resolution, encoding, and bitrate. Okay, so transcoding is what we actually want here, apparently. Let's try that out. Transcode.c. Alright, so applying some hard-coded filter graph on both audio and video streams. Well, that is crazy. Find AV calloc. Alrighty. Inform the decoder about the time base for the packet timestamps. This is highly recommended but not mandatory. Re-encode video and audio and remux subtitles. Guess frame rate. Trying to see if I could get some. In this example, transcode the same properties, picture size. Oh. Oh. In our case, we have just basically copied all the properties, all the codec parameters, I think. Right? Or is it not right? Okay, hold on a second. What happens if we... So let's do Control Z for the stuff that we have done because it just have corrupted the video. So let's just remove that stuff, all of it. Okay, cool. Let's just make sure we're all good at this point, real quick. Just to make sure before I do any modification, because I'm paranoia. Okay, cool. So it works right now. Okay, let's go back to where we are actually creating the output context, okay, where we copied the codec parameters. So here, we have copied all the codec parameters, I think. Now if we check these codec parameters, what we have here. Okay, so there is a frame rate, video only, number of frames per second for streams with constant frame durations. Should be set to 0, 1 when some frames have different durations or if the value is not known. Strange. I mean, let's just try to change it. So yeah, pretty much. Let's see. So what I'm gonna do, let's first of all see what that contains. So codec parameters, it does contain the width and the height. I don't think though I could just get away with just changing the properties here. I probably gotta use some function, honestly. But as you can see, the frame rate is 60 and 1. Okay, so 60 and 1. So 60 divided by 1, which is basically 60, right? Cool. What if I change that in the output without doing anything else? See if that works. So after copying all the parameters, I'm gonna actually override the parameter again. But hold on, I need to make sure this is video, or I mean, it doesn't really matter, I believe. Anyways, so yeah, let's just do this, bro. Codec parameters. Where the heck is this thing coming from? AI sucks, bro. Bit rate, no. Frame rate. Well, it's not as easy as 20. Oh my god, who the heck is doing this crap? I'm not sure where this stuff is coming from. Is it maybe some plugin that I have? What the heck? I have no clue. Or is it maybe an IDE thing? Whatever. AV rationale. Okay, so let's change this, let's say to 10. So 10 frames per second. I doubt this would work. I don't think this is how it's supposed to work. Probably need some actual proper function for this. But let's just try it out and see what's gonna happen. What can happen wrong? Expected expression before AV rationale. Is this C++? Is this C? What the heck is going on here? I mean, oh, this is C. Does that work? Are you happy? Okay, cool. So we're actually still in C. I have to, yeah, just for remembered. We have to make this into C++, yeah, for sure. Okay. Now let's actually see the video that is outputted from this. Where is it? Output MP4. Open in Explorer. Is it really 10 frames per second? It doesn't seem like. I don't think so. Did it just like completely disregarded that or something? Or maybe overrided it? Well, apparently it doesn't seem to work. So anyways, failed experiment once again. Anyways, let's actually convert this into C++ and hopefully we don't F it up. Let's see. Last time I tried this, I F'd it up. Okay, so Where's the video? Let's do this. Let's make sure that the output is good. Okay, so this actually does work. Cool. All right, let's actually make this into C++ right now and see how we could do that. Rename main.cpp. Is the stream fine, by the way? So the mic is on. No dropped frames. Perfect. Lovely. So let's actually turn this into CPP. And we're going to have some errors for sure, because C is not really C++. All right. First of all, we should use null PTR instead of null. So we're going to replace it in the whole project. There you go. You need a good IDE. All right, so what's next? And to be honest with you, I would just say this, really, instead of equal to null PTR. You know, just do this. Same thing with this guy. This is C++. And what's next? AV packet alloc. All right, narrowing conversion from unsigned int to signed type int is implementation defined. Let's ignore that for now. Cannot assign to type int from void. Oh yeah, so here they're using AV calloc. We could allocate our own thing, but let's just ignore that. Let's actually go to the errors right now, honestly. Interesting. Let's just, I think, try to static cast that. Hold on, let's do this. Static cast. I don't think we want static. We probably, let's try this. Taking address of temporary array. Ooh, I see. I remember. So these includes right here. They are C files, okay? So we should make sure to say, I think extern C, if I remember. Yeah, I think so. Let's try this out. What the heck? Hold on, I'm gonna come back in a second, like 5 minutes or so. Alrighty, back. Okay. So let me make sure mic on, camera on. Cool, lovely. All right, so let's see where we were. I have no clue. Let's try to run this. Alrighty. Taking address of temporary array. Ooh, that's interesting. So this is a macro. So it's, yeah, I see. So in C, this is not a temporary array, right? So this is an actual thing, like actual way of making a temporary array. Well, you know what? I'm gonna do something very simple. I'm just gonna remove this whole log packet and call it a day. It's not needed for the functionality of this program, so who cares? Let's actually remove all the logging. Or not really, let's just remove just that function, honestly. So, yeah. I mean, it could be useful for logging, honestly, but for now, it's okay. Let's actually convert this into a boolean in the whole project. Okay, so instead of ones and zeros, we're going to use true and false. Alright, so is that all? Jump to label end. What's wrong with that? C++ doesn't look like it likes jumping. Honestly, you know, since this program just like runs once and just exits, I mean, the operating system would just clean up all of this crap. So honestly, you don't even need that stuff. Let's just remove this whole crap, right? And we don't need to jump anywhere. We don't need to go to anywhere, right? So let's just remove all these go to ends from the equation. No need for go tos. Some people would kill you if they know you're using go to. Anyways, in C++ though, instead of using go to, you're supposed to use RAI though. But in C, since you don't have RAI, you kind of want to use this go to, unless if you want to go crazy. I mean, if you do care about proper, like perfect deinitialization. But of course the IDE here would complain about memory allocated is leaked. But well, who cares? I mean, the program would exit anyways. So who cares? Anyway. And there you go. It actually works in C++ right now. I mean, it's not perfect C++, but you got the point. It is C++. So let's see if this actually works properly. And just in case, let's just remove the first, like the video that we had earlier. Let's try again. Okay, so it does work in C++. Great. Now let's just do the, you know, the C++ craziness. avcalloc allocated memory is leaked here. We're gonna change that from avcalloc. We're actually gonna use actual C++ vector, I think. Pointer maybe null. Alrighty. Okay, there's no interesting warnings. So let's change this one. So instead of using avcalloc to allocate this array like this, we could just use, I believe, a vector, right? So let's include vector, of course, outside of this extern C. Oh my god, that autocompletion is turning me crazy right now, but anyways. I just reinstalled my whole system. That's why the settings of my IDEs are, you know, effed up. Anyways. Alright, so we need stream mapping size. Hold on, let me just comment this out, right? Pretty much. And let's say that this is an std vector. I think probably of integers. And yeah, stream mapping. And we're gonna give it the stream mapping size. Is that the case? Oh, it's already interesting. Let's remove this crap. And there you go. Cool. Now, just one last thing. If not stream mapping, well, we don't need this anymore. We're not using alloc and stuff. So if like there is a problem with allocation, you would just throw an exception basically. There you go. And here we're basically creating a vector of this size, I believe, if I'm not mistaken. Why it doesn't show me the overload of this function? What the heck? I don't know why. Well, anyways, so let's see where we have to change this up. Is there anywhere where we actually have to change this? I don't think so. Let's try this out. And I believe it works. Yep, it does. Cool. So it does work. Amazing. What are another thing? Since we removed that crap of the allocation and stuff, we don't actually need to put the packet here. We could just put it, you know, where it's actually being used, which is here. So AV packet. Actually, yeah, there you go. But I believe we probably have set it before that. There you go. Let's just remove this. Well, actually don't remove it. Let's just do this. I mean, we could use area here, like put it in a class and stuff, but I'm not gonna go that crazy right now. And yeah. But basically we only need that packet in this loop, not, you know, on the top there, basically. Makes the thing a little bit easier. Okay, what about this OFMT thing? Honestly, I mean, I think this is fine. So int const stream mapping size. Yeah, I think this is fine. Yeah, pretty much. This is C++. We could go crazier, but honestly, I don't think it's worth it. So yeah, I think let's see if we can do something else before we end the stream. Let me see this code. This is using the filter API of FFmpeg, which is way crazier. I haven't even checked up on that yet, but it's very, very useful. Like, it's kind of like nodes, you know, like Blender geometry nodes or shader nodes or something like that. That's what filters in FFmpeg basically. So yeah, I can't decode anything here. This is still too advanced for me. Hello, Freeso92. Welcome to the live stream. How's it going, man? Alright. Let's check some other example and see if we can do anything real quick. So there is this scale video. So I believe this is supposed to change the video scaling. What's up? Just exploring FFmpeg. Pretty much we have set it up FFmpeg with CMake in Windows, you know, just using the libav libraries. And then we basically have copied the C example in the FFmpeg repo. We have copied the remux.c file example. And we basically have gone through it line by line, explained it and debugged it, right? And after that, we just made some experiments, pretty much. just to see, like for example, we have made it so that instead of just converting the video from one format to another, it also mutes video by basically filtering out the audio packets. Yeah, just a small experiment. And after that, we have just made it, we have converted the C-like code into actual C++, and there we go. And yeah, that's pretty much it, what we have done this entire stream until now, I think, if I didn't miss anything. How is it going? So, fill YUV image. Ooh. Let's see this example and see if we can figure out something real quick. Otherwise, I think we're just gonna stop the stream for now until a next stream, until like I actually check out this stuff. Create a scaling context. Honestly, let's not mess with this stuff for now until I think to a next stream, and then we could look out into some other example. Today we have just checked out on remux.c and we have converted it into C++ and stuff. Yeah, so I think this was it for this stream, I believe, if I didn't miss anything. Okay, yeah, 2 hours pretty much. So this remaining 8 minutes, if there's any questions, please let me know. So other than that, we're gonna end the stream. So yeah, that was a lot of fun. And like, there's a lot of crap you could do if you know how to use FFmpeg, like if you master it. Oh my god, like, because like in this modern world, everything is about like encoding videos, decoding them, like streaming them, cutting them. Like we could try to make some application that cut up videos, or basically, or like let's just say make a video player. I mean, if you're really crazy, you could also make your own video editor using FFmpeg, or at the very least, let's say a video editor, but not like your typical video editor. You could use just like nodes, node-based video editor in some sense. Like there, I think you would use the filter API of FFmpeg and stuff. You could even go crazy, like let's say I know some Vulkan stuff, like basically using the GPU, you know, like accelerated, to do some accelerated operations using shaders on the video frames, right? And then let's say play them or something like that, or like do whatever using the GPU basically. That's very powerful. Like I think there is some API for FFmpeg to work with Vulkan, though I'm not sure if I'm crazy enough to figure it out. I mean, Vulkan is crazy. It's like its own beast, and FFmpeg is its own beast too. But like if you figure them out, like how to get them together, that's crazy, man. That would be epic. So yeah, that's too advanced for now. I think next video we're probably maybe gonna check out the scale video, and what else? I think there was another one. Yeah, the transcoding one too. And possibly I'm gonna like investigate if we want, let's say, to only include one part of the video, like let's kind of cut down the video into some parts or something like that. But yeah, that's pretty much it. Is there any question, guys, before we end the stream? So 5 minutes left pretty much. If there's any questions, let me know. And yeah. I mean, if we check FFmpeg and Vulkan, There you go, FFmpeg 6.1 or .1. 9 months ago is released with Vulkan video decoding. There you go. Or even CUDA, you know, the NVIDIA API. Yeah. But it's wild. Like video decoding, if you get into the nitty-gritty low-level details, it's mind-blowing. That's why FFmpeg is like one of the few like encoding and decoding, or like video processing in general, video and audio processing in general. So especially video, because it's insanely hard to do. And like, I mean, you could do it using some simple algorithms, but like if you really want the efficiency of today's video codecs and stuff, oh my god. You have to be a crazy genius, basically. So yeah, I think we have no questions, so I'm gonna stop the stream. So yeah, that was it guys for this live stream. Thank you all for coming in. Thank you for tuning in. So thanks for Marty Flowers, Theo Paris, and myself, Wo GG Gearing, and Friezo. Friezo, I think, is the only one who's new in the comment section. So yeah, that was it guys for this stream, and see you later. Goodbye everyone.